back. Sorry I had some audio problems there. Apparently my mixer does not like the USB extender I was using. So let me check my audio again, because of course I messed with some stuff. So I just changed random stuff and now I have to kind of change it back. It's a hardware problem all along. Alright, so here we are working on day 5, and this problem seems a little trickier than the ones I've seen so far, but I think I might have a clue here. So the deal is that we're going to go through an element and we're going to try and find the best days to buy stock and then sell it in order to maximize our return. So example 715364, the optimum stock purchasing you can do is basically to buy when it's 1, sell when it's 5, so you make a profit of 4, and then we're going to buy when it's 3 and sell when it's 6. And so if you add up that 3 and that 4, then you get 7. And so it's kind of tricky because you have to know whether you're better to hold or sell or whatever. But I'm still kind of thinking through it, but I think that a stack might help us out here. But also, it just kind of feels like maybe there's a naive solution, like basically a kind of a simple, greedy solution to this, where I basically just kind of say like, hey, I made a good profit here. I should go ahead and sell it because this number goes down. But I don't think that's the case, because you can imagine if these numbers were instead, we'll come down here. Oh, it kept what I started working on. If the numbers were instead 7, 1, and this weren't a 3, if this were, say, an 8 or 9, then it would have been better to hold off and, sell when it's 9, first of all. What about when it was 5? If it was 2 5s. Oh, I don't know. You got me thinking again. So what if it was a 4 here? I would still be better off selling a 4 and then doing the 2 for a total of 6, and then waiting for a 5. If this number is 3, then I'm better off selling. If the number's 5, it doesn't matter. It's better off selling. Oh, this is interesting. So I'm going to shrink this down a little bit, get rid of some noise here, make sure I totally understand this sitch. So if we're looking at 1516, I know that I can sell here 4, and let's change that a little bit. I know that I can come in here 1, and then here I see that I can make a potential $4. When I go to the next one, I can see that it's a big dip. And so what that means is that even if I've got another maximum later that is higher than the number that I just sold at, because I've got a dip, I know that I'm okay to eye that as a purchase, and if I've got a bigger one coming up, then I'll just sell it. So it looks like this problem is actually a lot simpler than it kind of seems. I think we'll see if I get the answer right first. So for let I equal 0, I less than prices, I plus plus. And I shouldn't code this out just yet. Let me grab an example, a couple examples, and then we'll try working through them in pseudocoding just to make sure so I don't end up spending a bunch of time going down a bad path. Alright, so what I'm talking about doing is iterating through the numbers once, which means this will be a big O of n algorithm, which means we're going to basically scale linearly with the input size. We'll do one operation for each input, roughly one set of operations. And I don't think there's an easier or better way to do that. The numbers aren't sorted or anything, so I think that the best possible runtime we can get is O of n, so we're doing good there. All right, and I'm not sure what the memory footprint will be yet, so we'll just kind of keep track of that, and we'll come back to that later. Get this out of our face. Alright, we need to return some sort of number. Call it some All right. So, const. So, what I want to do here is basically loop through the input. And if prices at I is, I'm looking for basically a low. I want to see when it's a low. So is less than our, call it buy price, then set the buy price. Prices at I. Okay. Likewise, if prices at I, or I guess I should say else, if prices at buy are greater than my sell price, then what we're going to do is set the sell price equal to prices at I. Else is the interesting case here. So it's not a new low, it's not a new high. So let's take a look at, let's kind of walk through this. And actually, nope, sorry, got distracted. The buy price should start out at prices at 0, and the sell price, I'll go ahead and set that at prices at 0 too. It's kind of goofy, but whatever. And then that means I could start at 1 here. So it just makes things a little bit easier. So let's think about this. So when we're looping through these numbers, we'll take them down here, give us a bit of room. This the buy price equals 7 because of how we initialized it. The sell price is 7. Oh my gosh. And the sum equals 0. So we're just going to walk through this, make sure it works. And we're starting at 1. So 1 is less than our buy price. So we're going to set the buy price equal to 1. Now 5. Okay, so sell price should definitely not be 7. So let's set that to negative infinity. All right, it's negative infinity. All right. Now we're looking at the 5 here. And this 5 is greater than negative infinity, I hope. And so we set that. And now we come to a 3. 3 is less than, or rather, it's not less than our buy price. It's not greater than our sell price. So at this point, let's go ahead and sell it and see if this algorithm works. So we're going to do sum equals buy price minus sell price. Do I need to reinitialize those values? So then I could say buy price equals infinity and sell price equals negative infinity. All right. Which means to make things more consistent, I really should start at 0 and just be consistent. All right. I like consistency. All right. So I'm going to go ahead and just delete these so it doesn't get so confusing. Now we're looking, okay, so these have been reset to negative infinity because we just did the math. Now we're looking at a 3. 3 is less than infinity, okay. So we can get rid of that guy. Now we're looking at a 6. Okay, sell price, that's good. Okay, we go to 4. It's not less than that. It's not greater than that. And so what we're going to do is add this to our sum. Sum plus equals. Okay, so that worked for that example. Now let's take a look at the other examples we got, and we'll just run through those quickly. And 1, 2, 3, 4, 5. So infinity, sell price is negative infinity, and our sum starts at 0. Excuse me. Okay, so first one, we're going to get buy price at 1. Then we're looking at the next one. It's not less than, so we set our sell price. Do it again. Sell price. So we can just kind of fast forward a little bit here. Price. So at this point, we're out of elements in the array. So this is a case that we have not covered yet. I need an else here. So it's basically if neither of these conditions, or if it's the last, geez. Oh, else, special case, I equals prices dot length and buy price is not equal to infinity. There might be a slicker way to do this. And sell price is not equal to negative infinity. So basically we have values for those. Then we need to make sure we do our sum here at the end. And this is a special case because like in this case I would have set here, so I would have gone on to continue. So I guess I could actually do this out of the loop. That's a little bit cleaner. So if buy price, and then I don't care about the length, if buy price is not equal to infinity and sell price is not equal to infinity, then we can go ahead and tack on that last cell. Okay, we've got one more example to look at, which is a descending order, in which case I should buy nothing. So let's set this again. Infinity, negative infinity, sum 0. And we get these numbers, 7, 6, 4, 3, 1. Buy price is going to be 7. Okay. Now we come back through. Buy price is now 6, 4, 3, 1. We never set infinity. We double check that neither side is infinity or negative infinity. And so we don't update the sum. And then we're good. All right, so I think this is a winner here. All 3 examples worked well, and I'm not, don't feel anything queasy in my gut. So I think we can basically just turn this into code, and we're practically there already, and see if it works. Anyone want to give me odds? I think I'm feeling maybe 75%, maybe 80%. That's pretty good. That's 80% that will hit run code, and it will work first time, no syntax errors or anything. Sell prices, okay. Jeez. All right. What happened there? Okay, here's our last case. If the buy price is not equal to infinity and sell price is not equal to infinity, then we're going to do that last bit there. Okay, no consoles.log or anything. Let's see. I'm saying 80% chance this is going to work. All right, input's down here. It's still running. Ooh, terrible. somehow returned a 7 or a 0 instead of 7. So yeah, hit that 20% condition. What happened here? I mean, sum never got increased. Buy price is infinity, sell price is negative infinity. So first I check if the buy price is, if the price we're looking at is less than the buy price, then we set the buy price. If the price is greater than our sell price, which is negative infinity, we should set the sell price. All other cases, we increment the sum by, oh, it should be the sell price minus the buy price. Okay. I'm kind of surprised to see that added to 0, but whatever. So now I'm going to say 90% odds this is going to work. Okay, so still didn't work. I don't think that this was the problem. We shouldn't. We definitely didn't hit that case. And so we're going to resort to our old friend console.log. And we're going to say buy price equals. We'll just do everything. We'll just do this once. Sell price equals sell price. Sum equals sum. And we'll do it one more time at the end. I guess let's do it after the special case. All right. This is not going to work, but we should have some better output here. All right. Okay, so we only went through this one time. We only got one printout, so it's something wrong with the loop. Man. JavaScript, right? Like, why did that even run? All right. Now it's going to work. We're at like 99% now. There could not possibly be any bugs left. Okay, this is impossible to read. It's also not the right answer. Okay. We're in that 1% chance of there being a bug. I wish I would have separated these. So initialize correctly. Buy price of 7 is good. Next one, we set it to 1, which is good. Okay. We came back through. Yeah, all right. Sell price is good. Sum is still 0. All right. So buy price is infinity. Sell price is infinity. And, oh, geez. Okay. So we set the sum, which is good. But what I didn't do is set the buy price again. So basically, when we see that there's this condition, we also, we don't want to set the buy price equal to this. We want to set the buy price equal to prices at I. Now, we are at 99.9999119's chance for this working. Okay. So let's go ahead and try those other custom use cases, test cases, just to make sure. But I think this problem is done. One, two, three, four, 5, and counting down. Okay. Any day now. Okay, answer 740, 740. We got it. So let me hide my shame here. Look for any obvious optimizations. I don't think so, though. We're not allocating new memory. We've just got these 3 variables, and so I have a feeling our memory footprint's going to be pretty good. Runtime's pretty good. We only look at the items once. Oh, yeah. So our memory for this is constant. So it's not dependent on the input size. Basically, we declare 3 variables, but that's a constant, so it kind of just falls away. I'm not declaring anything in the loop. So yeah, I mean, that's going to be a good algorithm. So people might have figured out how to do things. You can't buy prices, sell prices on price 0. Yeah, you're right. You can never buy prices at the end. And I think that's going to be accounted for because the sell price gets set to infinity. And so we catch that here. And you can't sell prices on 0. Right, because you haven't bought. Yeah, so the first run through, you always end up setting this because whatever value is here is presumably greater than, or it's going to be, less than infinity. So I think we're good. Am I understanding you, Gregory? See, I hate there's a long lag, so sorry if I'm just sitting here. I want to make sure I understand what you're saying. I think we've got that accounted for, though. I'm going to go ahead and hit it, see what happens. It's pending. Oh my gosh. This is probably exactly what you said, isn't it, Gregory? Yeah, I see what you're saying. So if we set it to 1, then I would have to set the price to prices at 0. Are you thinking like that? That would prevent me from ever setting sell price to the first item. Oh, okay, cool. So why was this case wrong? So somehow I got a 3, which makes me think that I added that number in. So I might bring those console logs back in. So in this case, I should have set the buy price to 2, sell price to 4. When we got here, I should have gone ahead and sold and gotten 2. But why did that get added back in? I set the buy price and the sell price to negative infinity. And here I check if that and that. So I'm surprised to see a wrong answer. Just going to back up here to get those things back in and run this test case and see what went wrong here. Okay, so buy price is infinity, just like we expected. That's the initial state. Set the buy price to 2. Cool. 2 and 4. Good. Now, something went wrong here. So this is good. But here, when we came back around, oh man. There's a logical error in my code. Because, excuse me, I can only set the buy price when I don't have a sell price. Oh man. Yeah, so what happened here is I came back around, I saw that 1 was less than 2. And so I changed my buy price. So I'm wondering now if I should only change the buy price when the sell price is negative infinity. So once I've decided to buy, I can't change my buy price. So that'll work for this case. I think. 241. Wait, what? Oh, sorry. Price equals infinity. Okay, so 2 and 2. All right, this always throws me off. This is the answer from when we submitted it, and this is from the actual run code. Okay, so that worked out good. Let's go ahead and check the other examples now. Just to make sure it didn't break anything. And what was the other one? All right. So how do the answers look? So the answers all worked. So let's go ahead and submit. I'm just gonna leave those console logs in there just in case. All right, and that did it. Oh, and then I dropped that optimization. So let's try that too. That should be fine. Save ourselves a little bit of work here. Micro optimization. I'll run the code. If you're not familiar with LeetCode, you get dinged for failed submissions. But you can run code all you like. Hey, did not click. There we go. I thought I deleted. Oh, I left some. Okay. All right. So runtime memory not changed at all. So we'll submit one more time, and then we'll go hit more details and see right in the middle. I'm surprised to see that so many people did so much better. Like this person ran in half the amount of time. Memory distribution, mostly low. Some people did go high. All right. So come over here and I'm going to submit it over here so I see the stats in another way. All right, so faster than 57%, less memory than 52%. I want to go see any other solutions. I really don't want to read C++, sorry. One-liner using reduce. Huh. I can't read that. Not understood. Crisp. I want to see this crisp O van time. All right, so profit. So one less variable to me. No, two less, because I also had I. I is already declared, okay. And so basically they're, okay. So they're saying, oh, is this what you're saying, Gregory, about starting a 1 and looking backwards? Basically, yeah, okay, they're looking to see if there's a profit, and then they set it. And then they don't need to keep a buy and sell price. They basically just, oh, cool. So they do kind of some smaller additions, and it adds up to the right answer. So whenever it's basically it's positive, they add it. Oh, that's slick. Okay. Oh yeah, overall it looks like these are pretty similar. Like nobody's figured out how to only look at the logarithm of inputs or something, so I think that's good. Yeah, this is an interesting problem. I don't know. I kept trying to make it harder than it was initially when I first read it. Luckily my microphone wasn't working then, so Gregory didn't get to hear me throwing out all sorts of crazy solutions. So I think that's going to be done for now. Thanks for stopping by. I am going to come back and stream later. I'm looking at, I'm planning on doing some work on Apache Beam today. I've got to look at it for some work stuff, and so I was going to try and do a little bit of project coding, maybe in like an hour or so. And it should be fun. It runs on top of data flow, which is what I was going to look for, which is Google GCP service, but also it can run on like Flink or Spark. And so it sounds like it's cool. It's like a nice abstraction. And I thought it might be fun to look at something that maybe most people aren't familiar with. It's kind of a, I don't want to say exotic, but it's kind of niche. So maybe it's fun, maybe it's terrible. I don't know. But thanks for stopping by. And Gregory, thank you so much for your help. Definitely got me thinking. So y'all have a good one.